Hello and welcome to a new unit on statistics, which is Unit 8, and we'll be talking about Lesson 1. Here are the three objectives for this lesson. Students will be able to explain the value and purpose of statistics. Students will also be able to explain random sampling. And finally, students will be able to determine whether or not a sample is valid. There is some new vocabulary for you to know and be able to work with. For example, statistics, the practice or science of collecting and analyzing numerical data in large quantities, especially for the purpose of making predictions about a whole from those in the representative sample. A random sample, a sample in which every element in the population has an equal chance of being selected. Representative sample, a sample that fairly represents each member of the population. And finally, prediction. It's an estimate or a guess about what will occur in the future or what will be true about a larger population. So let's think about those vocabulary words as we work on the think about it. Number one, Heaven is trying to determine what are the best restaurants in New Haven, Connecticut. She knows that it would be too time consuming to ask every single person in New Haven. So she decided to take a sample, which is a subset of a population, of the entire population of New Haven, and only ask 50 people. To do this, she decides to ask the question, "Do you like fast food?" to 50 random people that walk out of a Burger King. Her results show that 98% of people like fast food, and she concludes that the best restaurants in New Haven are fast food restaurants. So that's the situation. Let's look at part A. Do you agree with the results of her survey? Why or why not? I disagree with Heaven's approach because she is trying to figure out what the best restaurants in New Haven are, but her question and sampling are biased towards fast food. Biased means to be unfairly prejudiced for or against someone or something. So she should ask an unbiased question. B, provide a better question that Heaven could ask. So what could be a better question for her to ask? Her question asks if people like fast food or not, which is not what she is trying to figure out. Her question should have been, what is the best restaurant in New Haven? That question is unbiased. Yeah, sorry. Let's move on to the next page. Which of the four options below would represent a better method for sampling that Heaven could use? So we want to figure out what's a better sample of people to talk to figure out what the best restaurant in New Haven is according to those people. Would it be one, A, ask the first 50 people who go into a vegetarian restaurant? Would that be a better sampling? No, this is a biased approach, as she would be only sampling people who are going into this restaurant. She needs to sample a wider audience of people. What about two? Ask 50 high school students. No, this is also a biased approach, as she would only be sampling people who are in high school. She needs to sample a wider audience of people. What about three? Ask every 10th person who walks into her school. No, this is also a biased approach, as she would only be sampling people who are in her school. She needs to sample a wider audience of people. How about four? Ask every 10th person that she sees in the New Haven phone directory. And in the old days, we used phone books to look people up, believe it or not. Let's see. Well, this method is unbiased because it will be random and represents all parts of the population. Everybody in the olden days was in the phone book. All of the other options are biased towards one particular part of the population. She should ask 50 random people from different parts of New Haven that are not next to restaurants so that the results will not be biased towards a specific restaurant or a part of town near a certain restaurant. It's important to keep in mind that the question and strategy that have been used didn't result in accurate data of the population. Let's see what the key point is. We use random samples and statistical questions to make unbiased assumptions about populations. So the samples need to be random and the statistical questions need to be unbiased. So let's apply that key point. Exercise 1. Kenneth is in charge of playing music during lunch in the cafeteria at BAM. Before he chooses the music for tomorrow's lunch, he wants to design a way to gather input from a representative group of students at BAM. So what's he trying to do? Figure out what the favorite music is to be played during lunch. So A, what is a statistical question that Kenneth can ask? Let's see. What is your favorite musical artist or group to listen to? That's an unbiased question that he could ask people. B, how can Kenneth collect data from a random sample of students at BAM? How could he do this? How could he get his data? Kenneth is trying to determine what music to play at lunch by taking a representative sample. He should accurately sample the middle school as well as what music to play based on the data he collected. Here's what we know. Our population is all middle schoolers. One way to go about this is to ask every 10th scholar entering the school during morning arrival or leaving during dismissal could be the way to go about this. Notice the word could. It's not the only way, but this is a good way. It's one way. Here's what we know. Kenneth was able to collect the following data from 41 students at BAM. Create an appropriate graph to display the data. So part of statistics is after you collect data, you graph it and present it in such a way that people who look at your graph can make sense of it. We have to represent the findings in a data display. We can use a bar graph to represent the data that Kenneth collected because we are recording the frequency of answers collected. So let's look at our bar graph. Favorite types of music is the label for the graph. Number of students along the y-axis, types of music along the x-axis. We can make sense of this bar graph. For hip hop, there were 12 students who said this is their favorite. For classical music, 8 students. For rock music, 7 students. And for jazz music, 14 students. So those are the results of his sampling. Now, based on this data, let's look at this next part, D. Which music should Kenneth play in the cafeteria tomorrow at lunch? Why can he be certain that the students in his school will like the music that he chooses? Well, based on the data that was collected, he can make a prediction. According to the results, Kenneth should play jazz music during lunch the next day. Kenneth should be confident about the selection because the question that he asked is general and it avoids bias while allowing for multiple responses from multiple people. So he was able to talk to 41 people. These are the results that he got. The bar graph that represents the most people is jazz. So he can predict that jazz music would be something to play during lunch from now on, or at least tomorrow. E, how did we apply our key point for today to solve this example problem? Well, we had a key point, which was we use random samples and statistical questions to make unbiased assumptions about populations. So let's see. We actively considered the question we were asking and who we were sampling in order to avoid a biased representation, excuse me, of the entire population. In other words, we wanted to ask a question that did not lead anyone towards a particular answer. We also made sure to ask people at random as much as possible. So the key point for today is we use random samples and statistical questions to make unbiased assumptions about populations. So now it's time for you to practice.